Okay, so we have here a simply supported beam with an overhang. And we need to draw the shear and moment diagram using the equation method. So we have here the loading of 15 kilonewton, 25 kilonewton per meter, and a uniformly varying load of 25 kilonewton per meter. So we need to draw the shear and moment diagram. So the first thing that we need to do is to get our reaction. Okay, so if we are to solve for the reaction, wait, let me fix my camera. Okay, so to solve for the reaction of either of which, we'll be having a moment on either point A and point D. Okay, so summation of moment at point B. So all forces that are rotating clockwise should be positive. So what are those forces? So we have 15 negative times a lever arm of 2 plus 25, and it is rotating clockwise, so that is plus, times the span of 4 meters times the lever arm of 2. It is acting at the center. Next, you also have your uniformly varying load of 25, and it has a span of 6. It is rotating clockwise, therefore it is positive, times the span of 6 times 0.5 because it is a triangular load. Don't forget to multiply it by 0.5 if it is a triangular load or uniformly varying load. Then for the lever arm, it is from this point up to the center of this triangular load. Therefore, it is 4 plus, we know that the centroid of or the resultant force is acting 1/3 from the base. Okay, therefore we need the 2/3, so that is 4 plus 2/3 of 6. Okay, plus minus RD because it is rotating counterclockwise with a lever arm of 8 meters. Therefore, RD is equivalent to 96.25. Okay? To solve for RA, you can still use the summation of moment, but this time at point D. But it would be a lot easier if we're going to use the summation of forces vertical. So summation of forces vertical, or for all forces that are pointing upward, should be positive. So what are those forces? So we have negative 15 minus our plus 96.25 minus the load of 25 kilonewton per meter times the span of 4 meters. To cancel out the meter, para matitira na lang is kilonewton. Tama? Minus 25 times a span of 6 times 0.5, since it is a triangular load, plus RA is equivalent to 0. Therefore, RA is equivalent to 93.75. Okay? So the next thing that we need to do is to analyze it per segment. So how many segments are we going to use? First, observe your problem. So we have 4, we can say cut. So we have here first cut, second cut, third cut, and fourth cut. So nag-iiba yung loading per segment. So I'll say this is segment AB, segment BC, segment CD, and segment DE. Okay? So the first thing that I'll be analyzing would be segment AB. So for segment AB, the distance would be varying from 0 meter to 2 meters. Okay? So I'll cut this portion. Itong portion na to, ikakat ko siya. Ito na siya. This would be the free body diagram. So dito ako nag-cut sa port na to with a cutting plane AA prime. So I have the 15 kilonewton downward force. I have shear force AB. And I have moment AB. So from this, yung point kung saan ako nagpass ng cutting plane AA prime, I will fix that with, let's say that is point F. Okay? So from point F to, or from point 15 kilonewton to point F, that would be distance X. Okay? Now for shear, of course, it is simply summation of forces vertical. So shear AB, okay, so shear AB is equivalent to the summation of forces vertical. All forces that are pointing upwards are to be positive. So what are the forces present? So here on our free body diagram, the force present is only 15 kilonewton. So, and it is pointing downward, therefore it is negative 15 kilonewton. So this would be my equation for shear from segment A to B. Okay? So what are the distances from point A to point B? So x is equivalent to 0 meters. X is equivalent to 0 meters. Shear AB is equivalent to negative 15. At x is equivalent to 2 meters, shear is equivalent to negative 15. Okay? Next, we have here for the moment. Now, for the moment, it is simply the summation of moment with respect to point F. So, what are the forces that are going to rotate with respect to F? So, we have here 15 with a lever arm of X, and it is rotating counterclockwise, therefore it is negative. Therefore, this negative 15x would be my equation for moment for segment AB only. Okay? So, at x is equivalent to 0, x is equivalent to 0, m AB is equivalent to 15 times 0, therefore it is 0. At x is equivalent to 2 meters, x is 2 meters, so negative 15 times 2, that is negative 30 kilonewton meter. Okay? Next would be from segment B to C. I'll be analyzing segment B to C, but I will still include segment AB. Okay? So, drawing the free body diagram, yan. So, drawing the free body diagram, we have here, dito ako nag-pass ng cutting plane, BB prime. Okay? And let's say that is point G. So what are the forces present? We have negative downward 15, upward 93.75, and the uniformly distributed load of 25 kilonewton per meter. So we will also have here the shear BC and the shear the moment BC. Okay? The farthest member or the farthest fiber of your member would be the distance x with respect to the point of rotation. So that is, or point of cutting plane. So ito yung point of cutting plane ko, the farthest member is at point A. That is distance x. Okay? Now, habang lumalapit ka ng lumalapit kay point G, nagbabawas lang tayo ng distance. So, ang distance between 15 and B is 2 meters. Therefore, the distance of your uniformly distributed load would be x minus 2. Okay? Nagbabawas lang tayo ng distance. So, that is x minus 2. Ganon din si 93.75. So, parehas sila. Okay? So, for shear, it is summation of forces vertical. All forces pointing upward are positive. So, 15 negative plus 93.75 minus 25 kilonewton per meter times the span of x minus 2 times the lever arm, and we know that the resultant of 25 kilonewton per meter is acting at the center. Therefore, that is x minus 2 over 2. No. We will use that later sa moment rather. Okay? So, nasa shear pa pala tayo. We are still on shear. So, this is my shear. So, simplifying, negative 15 plus 93.75 is equivalent to 78.75 minus this, 25x minus 2. Okay? So, at x is equivalent to 2 meters, we use this equation. So, it is a function of x. So, at x is equivalent to 2 meters, we have 78.75 minus 25, 2 minus 2, 0. Therefore, this will cancel out. Magka-cancel out yan. Therefore, the shear at BC is 78.75. Okay? Next, at x is equivalent to 6 meters. So, this is 6 meters. So, ito yung equation natin. this is my equation, 78.75 minus 25, 6 minus 2. Therefore, that is negative 21.25. Therefore, the shear at BC is negative 21.25 at 6 meters. Okay. Now, for the moment, this time, what are the forces that are going to rotate with respect to G? So, what are those forces? So, summation of moment with respect to G clockwise rotating, positive. So, we have here 15 and it is rotating in a counterclockwise. It has a lever arm of X. So, that is negative 15. Next, we have 93.75 that is rotating clockwise, therefore it is positive, and it has a lever arm of x minus 2. So plus 93.75 x minus 2. Next would be the 25. So for the 25, it is a uniformly distributed load. It is rotating in a counterclockwise manner, therefore it is negative. So negative times the load, 25, times the span of x minus 2. Okay? So, yan muna. 25 yung load times the span of x minus 2. Now, for the lever arm, we know that it is acting at the center, or the resultant is acting at the center. Therefore, it is x minus 2. So, x minus 2 times x minus 2 is x minus 2 quantity squared divided by 2. So, nandito na yung span and the lever arm. So this is now my equation for moment BC. Take note, this moment equation can only be used from segment B to C. Okay? From B to C. Hindi mo siya pwedeng gamitin sa A to B. Hindi mo siya pwedeng gamitin sa C to D. Okay? Next would be, let's substitute. At X is equivalent to 2 meters distance, my moment is 15 times 2, negative 15 times 2 plus 93.75 times 2 minus 2. So, therefore, it will cancel out kasi 2 minus 2 is 0. Then, this will also cancel out because 2 minus 2 is 0. Okay? So, therefore, it is negative 15 times 2. That is negative 30. Okay? So, next would be at X is equivalent to 6 meters. Okay? So, function of X, that is 6 meters. So, we have negative 15 times 6 plus 93.75, 6 minus 4, 6 minus 2. Then, we have negative 25, 6 minus 2. So, 6 minus 2 quantity squared over 2. Therefore, the moment at BC is 85 kilonewton meter. Okay? Next, I will be considering segment CD. So, for segment CD, ayan. So, I already prepared it para mabilis. So, for segment CD, okay, so this is segment CD. I'll be redrawing the whole section from segment A to segment D, even though I am analyzing segment C to segment D. Okay, so redrawing the whole diagram, I'll be having my cutting plane in between C and D. So, dito ko idadaan yung cutting plane, CC prime. Okay? But the problem here that would arise is that, take note that at point of the cutting plane, so, kung nasaan yung point of cutting plane natin, doon nag-i-stop yung ating distance X. Okay? That would be our distance X from the farthest left fiber ng member. So, if I'll be having my cutting plane here, and nandito yung, this would be my distance X, what would be the equation if it would be a discontinuous uniformly distributed load? Okay? So, magiging X, take note, nandito yung cutting plane, 15X. Then, this would be 25 times X minus 2. But how about this distance? Take note, this distance here is varying. Okay? So, what we're going to do, if you see a problem like this, we are going to continue the uniformly distributed load. So, dadagdagan natin from this point up to the last fiber to the right part of your beam, we are going to extend the 25 kilonewton per meters. So, i-extend natin to hanggang dito. What if it is a triangular load? This triangular load is located here. Then what we're going to do is to extend it again. Then to get the value here, it is simply ratio and similar triangles. Okay? So here, what I did, redraw the whole diagram, then extend the 25 kilonewton per meter. So from point C to point E, I extended my uniformly distributed load. Then I simply copied my uniformly varying load. Now, to make it still valid or mathematically correct, since I introduced a load that is pointing downward, I need to cancel it out. So in order to cancel it out, I'll be introducing force, the same force, but this time it is pointing upward. So yung force pababa na 25 kilonewton per meter from point C to point E ay magka-cancel out since I also introduced uniformly varying load from point C to point D, which is opposite in direction. So if we will have it in equilibrium, it will still be 0. Okay? So ang ginawa ko lang, nag-extend ako, nag-introduce ako ng force pababa. To cancel it out, I'll be introducing again a force that is with the same magnitude but opposite in direction. You can see this technique, or you can see this method where during our discussion in deformation. Okay? So deformation, we introduced that. That's why I already gave you the modules in advance. Excuse me, I already gave you the modules in advance so that you can study. Okay? So for the distance, the farthest fiber is X from the point of cutting. So that this is my cutting point or cutting plane. So that is X. So this uniformly varying load, the distance would be X minus 2. Okay, take note, this is X. So babawasan lang natin ng 2. This time, yung inintroduce ko naman na uniformly varying load which is pointed upwards, the distance would be X minus 6. So this is 2 meters, this is 4 meters. Therefore, this distance is X minus 6. Likewise with the triangular load. Now, for the triangular load, take note, this is a uniformly varying load. So, kung distance mo dito, kung dito ka nag-cut ng cutting plane mo, iba yung load mo dito, iba rin yung load mo dito. That's why we're going to get the equation that will be dependent on the X value, or it is in terms of X. Okay? So, here is my uniformly varying load using the same triangle. For 6 meters, the load is 25 kilonewton per meter. Now, for a distance of X minus 6, what would be the load? So, W1 is equivalent to X minus 6 is equivalent to 25 is for 6 meters. Okay? W is for X minus 6, while 25 is to 6. Therefore, the load here, the load at any point in this uniformly varying load is 25 X minus 6 over 6. So that is W. Okay? Then we place our shear CD, and we also have our moment CD. Okay? So for shear, it is summation of forces vertical, or forces that are pointing upward are positive. So what are those forces? So we have negative 15 minus 25. So 25 plus from this point to this point, so that is distance X minus 2. So that is X minus 2 plus 93.75 with a distance of X minus 2 again. No distance yet. Span. This X minus 2 here is the span. Take note, we are still on shear. So 25 times the span of X minus 2 plus 93 plus 25. So, yung inintroduce natin, 25 with the span of X minus 6 minus the uniformly varying load. Yung load natin is the equation W1. So, that is 25 X minus 6 over 6. So, that is minus 25 X minus 6 over 6. Take note, ito pa lang yung load. Now, for the span, yung span niya is x minus x minus 6. So, x minus 6, this is the span. And take note, it is a uniformly varying load. Therefore, it is multiply it by 0.5. So, simplifying, negative 15 plus 93.75, that is 78.75. Then minus 25x minus 2, 25x minus 2, plus 25x minus 6. Then we have here x minus 6 times x minus 6, magiging x minus 6 squared times 0.5 over 6. So this will now be my equation for shear at point CD. Okay? So at x is equivalent to 6 meters, substitute natin 78.75 minus 25, 6 minus 2, that is 6 minus 2, that is 4, yeah, plus 25, x minus 6. Take note, pag nag-zero itong value na to, nasa parenthesis natin, or nag-negative siya, simply cancel out the term. Okay? Do not simplify these terms. I repeat, wag mong isi-simplify itong terms. Do not expand. Okay? If nag-zero or nag-negative yung value sa loob ng parenthesis, just simply cancel it out. Okay? So this will cancel out, this will cancel out. So it is 78.75 minus 25 times 6 minus 2, that is negative 21.25. Okay? At x is equivalent to 10 meters, you have x is equivalent to 10. So this time, 78.75 minus 25, 10 minus 2, okay. 10 minus 6, okay. 10 minus 6, okay. So we will be using the whole equation. Substitute the value of 10 to your x. Therefore, the shear at CD is 54.58 kilonewton negative. Okay? And for the moment, what are the forces that are going to rotate with respect to point of the cutting plane? So we have 15 times a distance of x minus 25 with a span of x minus 2. Take note, this is x minus 2. Then, the lever arm is located at the center. So, x minus 2 over 2. So, x minus 2 for the span, x minus 2 over 2 is for the lever arm. Plus 93 because it is rotating clockwise times is lever arm of x minus 2. Plus 25, ito yun, plus 25, it is rotating clockwise, times a span of x minus 6, so x minus 6, times the lever arm. So the lever arm is located at the center, so x minus 6 over 2, x minus 6 over 2. And lastly, we have the uniformly varying load. So we have the W, it is rotating counterclockwise, therefore it is negative. W, what is W? 25 x minus 6 over 6. So we have 25 times x minus 6 over 6. Now, what is the span? The span is x minus 6. Now, for the lever arm, we know that it is 1/3 from the base. And take note, the base is located here. Therefore, the distance is just 1/3. 1/3 of x minus 3, x minus 6. So the location of the resultant is x minus 6, that is the span, over 3 since it is 1/3. Pag nakabaliktad yung triangle mo, nakapaganito yung triangle mo, and dito yung cutting plane mo, nandito yung 1/3. Therefore, ang gagamitin mo dito is 2/3. But since your orientation of the uniformly varying load is this way, it is 1/3. Okay? Times, take note, it is a triangular load, so multiply it by 0.5. So, simplifying this equation, it would be this. Okay? So, at x is equivalent to 6 meters, x is 6 meters, substitute 6 meters to your equation for moment at point CD. Take note, this moment equation can only be used at this segment. Hindi mo pwedeng gamitin sa ibang segment. Analysis ng ibang segment. Okay? Therefore, the moment at CD is 85 kilonewton meter. Now, at x is equivalent to 10 meters, substitute the value of 10 meter to your equation. Therefore, the moment CD at 10 meter is negative 44.44 kilonewton meter. Last segment would be segment DE. Okay, so segment DE. I'll be analyzing segment DE, but I will still include point A to point D. Okay, so all in all, it is the whole diagram. So it would look like this. We're drawing the free body diagram. Again, since that uniformly distributed load ended up at point C, I am going to extend it to point E. Then I'll be introducing the same magnitude of load, but it is opposite in direction with that I introduced in CE para magka-cancel out pa rin sila. Okay? So, ganito yung naging itsura. Then, copy the uniformly varying load. So, this time, my cutting point would be in between point D to point E. Okay? So, again, from the point of cutting, the farthest fiber to the left would be at the distance X. So, the distance of 93.75 is X minus 2. The span of 25 kilonewton per meter is X minus 2. Then, this one, the load that I introduced is X minus 4 meters minus 2 meters. Therefore, it is X minus 6. Then, for the 96.25, it is X minus 10. The distance is X minus 10. Then, I have here my shear DE and moment DE. Okay. So, for shear, summation of forces vertical, all forces that are pointing upwards are positive. So, shear DE is equivalent to negative 15 minus 25 times a span of X minus 2 plus 93.75 times 93.75 plus 96.25. Then, here we have the uniformly varying load, which is pointed upwards. Therefore, it is 25 times the span of X minus 6. Then, for the uniformly varying load, the load is the W. So, asan yung W natin? Ito. So, we have here the W is 25 times X minus 6 over 6. So, take note, yan pa lang yung load. So, the span of that uniformly varying load is X minus 6. So, that is X minus 6. And it is a triangular load. Therefore, it is to be multiplied by 0.5. So, simplifying, shear DE is equivalent to 175 minus 25 times X minus 2 plus 25 times X minus 6 minus 25 times X squared times 0.5 over 6. So, at X is equivalent to 10, substitute the values of 10 to the X here. Shear DE is equivalent to 41.67. At X is equivalent to 12, substitute the value of 12 on all of the values of variable X here. Shear DE is equivalent to 0. Okay? Now, then for the moment, by the way, so for the moment, summation of forces with respect to the point of cutting, all forces that are rotating clockwise are to be positive. So what are the forces? We have negative 15 times a lever arm of X, 25 times a span of X minus 2. So, yan, X minus 2. Now, for the lever arm, it is X minus 2 over 2 kasi nasa gitna. So, X minus 2 over 2 plus 93.75 rotating clockwise times a lever arm of X minus 2. Then, for the 25, that I introduced here, yung upward, we have 25 times a span of X minus 6. Then, for the lever arm, it is X minus 6 over 2 plus 96 over 25. So, ang distance niya is x minus 10. So, that is x minus 10. Then, for the varying load, uniformly varying load, we have 25 times x minus 6 over 6. This is the y. Ito yung y pa lang. Then, the span is x minus 6. Then, take note that the resultant is acting 1/3 from the base. So, therefore, it is x minus 3 over 3. So, that is 1/3 of x minus 6 times 0.5 since it is a triangular load. So, this is now my moment equation for segment DE. Again, it is just for segment DE. Now, substitute the value at x is equivalent to 10. The moment DE is equivalent to negative 44.44 kilonewton meter. At x is equivalent to 12 meter, the moment DE is equivalent to 0 kilonewton meter. So we are now ready to draw our shear and moment diagram with given those values. Okay. So imagine wala pa dito yung ating shear and moment diagram. So this is the shear, this is the moment. Imagine wala mo na yan. So first is we have the shear. So for the shear, we have at 0 meter, what is our shear? Negative 15. So from 0, go down to negative 15. Then, at x is equivalent to 2 meters, the shear is negative 15. So plot mo yung negative 15, connect it by a straight line. Okay? Then, next, tapos na tayo sa segment AB. Next naman, punta tayo sa segment BC. At x is equivalent to 2 meters, what is shear BC? It is 78.75. Plot. Then, we have 15. Next. At 6 meters, shear BC is negative 21. You have your negative 21.25. Connect by a straight line. Take note, we have the degree of load. Okay? So, if ganito yung ginamit sa unang if ganito yung ginamit sa load diagram, ito load diagram, expected na yung magiging itsura sa shear diagram would be a uniformly distributed load. Then for the moment, it would be a uniformly varying load. Okay? So, this is 0 degree. This is first degree. Now, pag ganito yung ginamit sa shear, sa load diagram, ito ang magiging itsura ng shear diagram. Then, for the moment diagram, it would be a parabolic curve. This is second degree. Ito yung sa load, ito yung sa shear, ito yung sa moment. But, if for the load diagram, gumamit na ng first degree, take note, sa shear diagram, it would be a second degree. Then, for your moment diagram, it would be a third degree curve. Okay? So, dito, we have a point load. So, we have a first degree. We have a uniformly distributed load. We have a first degree. For 0 degree ito, first degree for the load, for the shear diagram. Dito, ang ginamit natin dito is first degree. So, expect na second degree ito. Likewise with this. So, how are we going to plot this? Okay? So, dito kasi, pwedeng maging ganyan yung curve mo or pwedeng maging paganyan yung itsura ng curve. Okay? This will now be dependent on your slope. Okay? So, for the slope, for the shear, the derivative of shear with respect to x is the load AB. Isn't it that when we are getting the derivative of a function, bumabalik tayo. Okay? Bumabalik tayo sa differentiated function. Or bumabalik tayo ng isang step. Okay? So, the derivative of the shear is the load. So, ano yung magiging slope dito, it would be the load here. So what is the load between A and B? There is none. There is 0. Therefore, the slope here is 0. That's why it is 0. Next, dito tayo at this point. So what is the load at point B? So the shear BC, so the shear BC is equivalent to the derivative of shear BC with respect to x is equivalent to negative 25. If it is positive, pag ganito yung itsura ng ating slope. Okay? If it is negative, pababa yung itsura ng ating slope. Okay? So, since dito, it is positive negative 25, it is pointing downward, therefore it is 25. And it is coinciding with the point here. Yun yung slope natin dito. So, that is 1 horizontal, 25 vertical. Negative pababa. Next, at point C, what is the load at point C? The derivative of shear CD at 6 meters. What is the load? It is 0. Therefore, it is, the slope there is 0. Pag 0 yung slope, it is a straight line. Okay? Okay. So, from there, makikita natin na straight line. Dapat, ito yung mga point of tangency natin. Okay? Yan yung point tangency. Next, dito naman, what is the load at point D? Okay? So, using a similar triangle at 6 meters, it is 25. So, what would be the load at 4 meters? So, the load at 4 meters is 16.67. So, therefore, the load here is 16.67. So, the derivative of shear CD with respect to x is simply the load at point D. So, that is negative 16. And since that is negative 16, so at this point, sa 54.58, take note, shear 54.58, where is that? Ayun. The shear at 6 meters is negative 21.25. Dapat parehas yan, ha? Kasi, though magkaibang equation sa segment CD and sa segment BC, pero isa yung point natin at 6 meters, dapat parehas yung parehas yung shear unless positive at negative. Okay? Pero this time it is both on the negative side, so dapat parehas. Since wala naman tayong nakalagay na reaction dito. Okay? So, saan na tayo? So, we have here ayun. So, we have here the load here is 16.65. Ayun. So, the load here is 16.65. So, at this point, yan yung, lagyan mo yung point natin. So, that is 16.67. Okay? Now, since it is negative 16.57, ayan. So, maglilin siya downwards. Okay? And, andito yung point ko. Dito yung 54.58. Then, this is 21.25. 21.25, 54.58. Dapat, etong magiging point of tangency nila. Kumbaga, habang papalapit yung curve natin sa point of tangency, papalapit din sila sa papalapit din yung ibang parts ng curve sa point of tangency. So, ibig sabihin, hindi pwedeng paganito yung curve natin kasi hindi siya lumalapit sa slope natin. Dapat lumalapit yung curve sa slope until it reaches the point of tangency. So, since that is the case, ang magiging itsura ng curve natin, since papalapit siya sa line or sa slope natin is pag ganito. Okay? So, papalapit ito sa slope natin, papalapit ito sa slope. Compared to this, hindi siya papalapit, papalayo siya sa slope. Therefore, this is erroneous. This is the correct diagram. So, from a straight line from this point to this point, magdodrawing ako ng paganon. Okay? Now, at point D. Nasa point D na tayo. Okay, so we have there at point D for segment, ayun, for segment D. Eto. So, for segment D, the shear is negative 54.58. Then, ito na yon. Then, at D to E, the shear is 41.67. It is positive. Therefore, dito, parehas lang. The load here is 16.67. And the load here is 25. Okay? The shear 10 meter, or the shear, the derivative of shear with respect to x at 12 meters, with respect to 12, with respect to x is negative 25. So, pababa ulit siya. Okay? So, take note, we have here, this, the slope natin is 1 over 16.67. Then, yung isa naman, 15. So, medyo mas slopey siya. Pababa. Okay? So, this is 25:1. So, dito yung point of tangency. Take note, yung curve natin papalapit sa slope. So, pag ganito yung magiging itsura niya. Okay? If it so happen na itong sa last is 0 yung load natin dito, then pag ganon. Kasi ito yung 0 line, so dapat didikit yung slope natin. Pag ganyan. And pag ganyan yung ating line of tangency. Okay? So, this is now my curve. So, connect it with a smooth curve. Smooth curve, smooth curve, shade. And this is now my shear diagram. Okay? So, 0 degree, first degree, second degree, second degree. Now, for the moment, ipa-plot na naman natin siya. Now, for the moment, take note na dito na tayo sa segment AB. So, for segment AB, at x distance 0, it is 0. At distance 2 meters, it is negative 30. So, 0, negative 30. Yung sinundan mong shear is a uniformly distributed load. Therefore, it is a first degree. So, connect it with a straight line. Okay? Next would be segment D, BC. So, for segment BC, the moment at 2 meters is negative 30. Then, the moment at 6 meters is 85. So, ito yung 85. Now, take note, I repeat, at the point of 0 shear will be the point of maximum moment. So, ibig sabihin, itong 85, it is not the highest value. May mas mataas pa sa kanya. Okay? So, this is a first degree curve. Therefore, ang curve natin dito sa moment would be a second degree curve. Again, the problem is, ano magiging itsura niya yan? Pag ganyan, ito yung points natin. Okay? Magiging paganyan ba siya or magiging paganyan? I-base mo siya sa slope. So, for the slope, the derivative of moment with respect to x is babalik lang tayo one step pabalik. So, that is the shear. So, ano yung shear natin dito? The shear here is negative 15. Therefore, the slope here is 15. And this is the point of tangency. Next, here. The shear, the derivative of moment with respect to BC with respect to x is the shear BC. So, what is the shear here? You have 78.75 and that is positive on the positive side. So, since medyo mas mataas, kunyari, this is 125, expect mo na mas slopey si 1 over 78.75. Tama? So, 1, then this is 78.75. So, mas slopey siya. So, from there, from that point, negative 31, I'll draw my slope. Okay? Then, the point of maximum shear, take note, so point of maximum shear is the point of zero shear is the point of maximum moment. Now, for maximum moment, always remember that the slope is 0. Because the shear here is 0, the load here is 0, therefore, the slope here is 0 then. Okay? Next, doon na tayo kay 85. So, kung yung slope mo is 0, tapos nandito si 85, is it this way or is it this way? Okay? Now, take note, it should be connected by a smooth curve. But to verify your answer, tignan mo yung slope mo dyan. The derivative of moment BC at 6 meters is, with respect to x, is the load. So, ano ba yung load natin dyan? Negative 21. So, ano bang itsura ng negative? Downwards. Tama? So, if this is 0, then it is negative 21. Dapat papalapit yung curve mo sa slope. Okay? So, ganito ang itsura niyan. So, connect it with a smooth curve. Okay? Next, we have segment CD. Okay. So, for segment CD, at x is equivalent to 6, it is 85. So, 85 pa rin tayo dito. Then, at x is equivalent to 10, yung moment natin is negative 44. So, nandito na tayo sa negative 44. Again, andito ka na. Then, nandito yung negative 44 mo. Ito yung 85. Ito yung negative 44. The question is it this way or is it this way? Okay? Now, punta ka sa 44. Then, derive your slope. Ano bang slope natin dito? So, the derivative is the load. Ano ba yung load natin dyan? Or yung shear natin at this point? The derivative of moment, CD with respect to dx at 10 meter is negative 54. So, that is negative. So, since it is negative, sloping downwards. So, therefore, your curve will look like this. Ganito yung curve. And lastly, for segment DE. Now, for segment DE, ito. The moment at DE at 10 meters, so tama, negative 44. Tama yung equations natin. Then, at 12 meters, it is 0. Now, the question is, ito yung curve mo, and ito yung 0. Is it going to be this way or is it going to be this way? Okay? Now, the best thing to do is to check your slope. So, the derivative of moment DE at 12 meters is the shear at 12 meters, as 10 meter rather, is 41.67 and it is on the positive side. Therefore, it is positive. So, ano bang itsura ng positive slope? Pataas. Okay, so more or less, your slope will look like this. And you have a zero shear here. So, to verify those zero shear, papalapit silang dalawa. Zero shear, positive. So, papalapit. So, this is how your shear diagram would look like. So, shade, 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 label. I-label mo yung mga slope. I-label mo yung degree. First degree, second degree, third degree curve, third degree curve. Therefore, that is your shear and moment diagram. But before we end, we need to know kung ano ba yung maximum value ng moment natin. Okay? So, the first thing that we need to do is to determine distance x. Alamin natin itong distance na to. Okay? What is this? X distance. Okay? So, para makuha natin itong x distance na to, take note that this distance is segment BC. Balikan natin yung segment BC natin. Then, kopyahin natin si shear equation natin. So, this is our equation for shear. So, copy the equation for shear. Take note, point of zero shear, point of maximum moment. So, pag zero yung shear natin, we can get our distance, x. Having our distance, x, isa-substitute natin yung x value natin sa equation natin for moment at segment BC. So substituting the distance, which is 5.15 meters, substitute natin sa ating moment equation here, negative 15 times 5.15 plus 93.75 times 5.15 minus 2 minus 25 times 5.15 minus 2 quantity squared over 2, the maximum moment at BC is equivalent to 94.03 kilonewton per meter. Therefore, the moment here is 94.03 kilonewton meter. And that is how you get your maximum moment.